Hello dear students, very good afternoon all of you. Here we are going to start chapter 3 of class 8 physics, that is force and pressure. Basically the topic is very interesting. Force and pressure both are related to each other. Okay? In this contrast, we have to study about force and then turning effect of force. Later, we have to move on the topic pressure. Pressure exerted by liquid and atmospheric pressure. The whole summary of this chapter is this. Now, I am going to start the first topic, that is force. What is force? Force is basically an external agent which causes or try to cause in the body a change. That means change in a state of rest or change in a state of motion. If an object is in rest, force try to change its state and make it in the motion. While it also causes, there is a change which tries to cause a moving object in rest. So, a question with you all, that what is force? Come to the point. An external agency that change or tends to change the state of rest or motion of a body is called force. Basically, force is an external agency which change or tends to change the state of rest of motion or a body is called force. Okay? For example, let's say that this is a stick and I am going to change its state as it is in a straight line. Just I am changing and try to bend it. Okay? It means that what I am applying to bend this stick, that agency is called force. I am just applying some force by two hands on this stick to bend them. Okay? That external agent which try to change its shape is called as force. Okay? You may also understand by another example. Let's say there is a duster. This is just lying on my palm. Okay? And if I am applying some external agent and it just make a change, that there is a change of state of position or it start moving, the duster starts moving, and the cause which I am causing, which I am applying, is called as force. Means that force is an external agency that change or tends to change the state of rest. The structural rest, and I have just changed its state of rest. Okay? That is called as force. Force can be changed the shape of an object or the direction of a moving body. Definitely, a good example, the shape I have changed the shape of a stick by applying force. Okay? By changing the direction of a moving object. Okay? A moving body. For example, if you are riding your bicycle and you find a turning where you apply some force on the handles of the bicycle, that cause the change in the direction of the bicycle while it is moving. If you saw your father riding motorcycle or driving car, definitely he is applying repeatedly some force on the steering that to change the direction of the car. Okay, dear students, here it means that force can change the shape of an object or the direction of motion of a moving body. Okay, now come to the point. Force has a formula. Force is a vector quantity. Okay, it has magnitude as well as direction. In a particular direction, force will change or cause, affect. Okay, that's why it has two things, that is magnitude and direction. Okay, that's why force is called as a vector quantity. Okay, now the standard unit of force in SI system is Newton. Okay, the name of great scientist, honoring great scientist Newton, we have given what SI unit of force is Newton. Okay, the formula for calculating force on a body is F is equal to mass into acceleration. I hope you know it, or if you are not knowing, just remember it. Force is equal to mass into acceleration. Okay, in short, if you write F is equal to ma. Okay, mass into acceleration. Force on a body having mass m and the body has acceleration a. That means that magnitude of force is equal to mass into acceleration. Okay, the SI unit of force is Newton, which I make you understand why we have taken Newton, because Newton has developed many theories related to force. Okay, and to honor him, we have just given that the SI unit of force is Newton. A commonly used unit to measure force is kgf. Basically, in day-to-day life, we use a common unit that is called kgf. Its full name is kilogram force. Kilogram force. kgf can be defined as the minimum force required to lift an object of mass 1 kg vertically upwards. Okay. kgf. Let's say that this duster is of 1 kg, and if I am holding this duster in this way and just trying to lift it, I have to apply some force. The minimum force applied by me on this duster of 1 kg to lift vertically upward, that minimum force is called as kgf. Okay, 1 kgf is equal to 10 Newton approx. Okay, why I have taken approx? Because Z is not fixed all over the earth. Okay, that's why we have taken approx. It is 9.8 Newton somewhere and somewhere it is 10. That's why we used to take as a approx value, that is in Newton. Okay, different types of forces. Different types of forces which we tackle in our day-to-day life are here. For example, gravitational force. Force that attracts this duster towards the earth, that force is called as gravitational force. If we are leaving this chalk here, it will move down towards the earth, towards the center of the earth. That force applied on this chalk is called as gravitational force. Okay? Magnetic force. Magnetic force. Force exerted by a magnet to the iron filings which attracts them. That force is called as magnetic force. Electrostatic force. The force between two charged bodies which called as electrostatic force. When positive charge and negative charge appears on two body and they will attract to each other, or if the same charge appears on the body, that is negative or negative or positive, then they will repel each other, and that force is called as electrostatic force. Now muscular force. Muscular force, the force we apply, we means as human, by applying by muscles, the force applied by muscles. For example, I am applying force to move this duster. This is called as a muscular force. Okay? Frictional force. Frictional force, as I am rubbing some point on this floor. Okay? For example, I am just rubbing. The force between the duster and the board is called as frictional force. As I am writing, if I am writing, and if there is no frictional force between board and chalk, there will be nothing written on the board. Okay? Due to the frictional force here, it is unable to write. Okay? For another example, if you are rubbing two hands of yours and you feel there is a heat generated between the palms, that force, that heat generated due to the frictional force. Okay? Now these types of force we will tackle in the courses in physics later on the higher classes. Now coming to the main topic of our this chapter 3, that is force and pressure. That topic is turning effect of force or moment. Basically, first we have to understand what is turning effect of force. For example, if this duster is like this, okay, and I am applying force here, I have to apply more force. While if I will apply some force, little force, rather than this here, a little force will turn this duster like this. Okay, this force is called as turning effect. Okay, if we see the doors of Almira, the doors of our gate, which is fixed on a particular, and there is a handle to some side of the door, to one side of the door. Okay, this hinge point is called pivot point, that is a fixed point of a door, and we apply some force on the handles of door, and we find that door is rotating, door is opening and closing. Okay, due to the turning effect. Okay, we apply a little bit force, and there is a product of force and displacement, that is called moment here to rotate that door. Okay, turning effect. We use also turning effect or moment to open or tight a nut by a wrench also. Okay, by the help of wrench, spare parts, we just try to tight a nut or open it from a particular point. Okay, the turning effect of force about a fixed point, that is pivot point, is known as moment of force. For example, if there is a fixed point and there is a distance, a length of radius, and at point A I am applying force F. Okay, the product of distance and force give you the moment. Okay, for calculating moment, the moment of a force is perpendicular. The moment of a force is calculated by the product of the magnitude of force and the perpendicular distance between pivot and the point of application of force. Okay. For example, if there is a pivot here and here I am applying on point A, I am applying force. Okay. The product of the magnitude of this force and the perpendicular distance, okay, gives the moment. To denote moment, here I have taken capital M, that is M, that is moment is equal to force into perpendicular distance. Force into perpendicular distance. Okay. So SI unit of moment, SI unit of moment will be Newton meter. As we know that SI unit of force is Newton product and SI unit of distance is meter. So SI unit of moment is Newton meter. Okay. Now come to the point. CGS unit. CGS unit is dyne centimeter. Dyne centimeter. Okay. Because CGS unit of force is dyne and CGS unit of distance is centimeter. So it will be dyne centimeter. 1 Newton meter is equal to 10 to the power 7 dyne centimeter. There is a question with you all. It should be, sir, why 1 Newton is equal to 10 to the power 7 dyne centimeter? How it can come? Please explain. Okay? I am just going to explain you how 1 Newton is equal to 10 to the power 7 dyne centimeter. Okay? You have to remember 1 Newton is equal to 10 to the power 5 dyne. Okay? 1 Newton is equal to 10 to the power 5 dyne. We also know that 1 meter is equal to 100 centimeter. 100 centimeter or 10 to the power 2 centimeter. Okay? Okay, dear? Sir, how to come? Okay, just you have to learn it. 1 Newton is equal to 10 to the power 5 dyne. Okay? In higher class, I will explain you how to do. Okay. Now, 1 Newton into 1 meter, that is equal to 1 Newton meter. That is equal to 1 Newton is equal to 10 to the power 5 dyne. Now, into 1 meter. 1 meter is equal to 10 to the power 2 centimeter. That means 10 to the power 5 and 2. If base is same, power will be simply added in product. Okay? So 5 plus 2 becomes 7 dyne centimeter. Okay? Okay? That's why 10 to the power 7 dyne centimeter. That is 1 Newton. Okay? I hope you all understand this calculation. It is so simple to understand. Okay, dear. Now, in the next video, we will do some problems on effect of moment, and we have to learn some applications of moment. For example, if we are opening door, is the best example of moment. Okay? If you will see, I am making a demonstration by moving the camera to the door. Okay? Here it is. This is the handle. This is the pivoted point. This door is fixed. Okay? And I am applying some force on this handle, and this door is just moving. Okay? This is the best example of a moment. Here, the pivot point, here I am applying force. There is a perpendicular distance between the point of pivot and the point of application of force. And the product of this force and the pivoted point is called as moment. Okay? Thank you, dear. Please read this through the book also and make me realize that you are understanding it. Okay? Thank you.